Good afternoon, everyone. It is Sunday, June 7th, 2026, and welcome back to another El Niño update. And I want to be upfront with you right from the top of this video. What I'm about to share with you today is not good news for the planet. We are now 2 days removed from our Friday update, and I want to take this Sunday to really sit back, zoom out, and give you the full picture. Because I think a lot of people still don't grasp how serious this El Niño is actually becoming. Now, if you are brand new here, welcome. These updates go deep. We don't just skim the surface. We look at the raw data, the sea surface temperatures, the subsurface anomalies, the atmospheric coupling, the model guidance, all of it. So if that kind of detail is what you're looking for, hit subscribe right now and turn on notifications, because I'm going to be doing these every single week now, likely every Thursday going forward, given how quickly this situation is evolving. Let's get into it. Let me start with the big picture, because I want to make sure everyone watching understands where we actually are right now before we talk about where we're going. As of June 4th, which is the most recent sea surface temperature anomaly data we have available, the central and eastern Pacific has continued to warm. And I mean that in the most significant sense possible. Looking at our regional Niño indices, the Niño 1+2 region is sitting at 2.59 degrees Celsius above average. That's the far eastern Pacific, right off the coast of South America. Now, 2.59 degrees might not sound like a massive number in isolation, but I want you to understand something. We are in early June. We are at the very beginning of meteorological summer. For that region to already be running that far above normal at this point in the calendar is genuinely alarming. The Niño 3 region is at 1.66 degrees Celsius above average. The Niño 3.4 region, which is the primary benchmark index that NOAA and most climate agencies use to officially classify El Niño events, is sitting at 1.4 degrees Celsius above average. And the Niño 4 region, which is the Central Pacific, is running at 1.1 degrees Celsius above normal. Now, to give you context on what that means collectively, those readings, taken together, are already reflecting a moderate to near strong El Niño profile, right now, in early June. That is not where we should be at this point in the year, and that's exactly why I'm doing weekly updates. Let me just reinforce that point with one more data comparison, because this really put things in perspective for me when I first looked at it on Friday. We have data tracking back through the 4 most notable Super El Niño events in recorded history: 1982 to 83, 1997 to 98, 2015 to 16, and the most recent significant event in 2023. When you plot the current 2026 El Niño's sea surface temperature trajectory against all 4 of those events at this same point in the calendar year, June, the current event is warmer than every single one of them. Every one. The 1997 event, the 2015 event, the 2023 event. We are ahead of all of them. We are breaking records for this day and this month. The actual sea surface temperature in the Niño 3.4 region is sitting right now at approximately 29.15 degrees Celsius. For reference, the 2015 event was only at 28.7 degrees Celsius at this same point. Now, we are near the climatological peak for raw sea surface temperatures in that region, meaning temperatures in absolute terms tend to be near their annual high right around now. But if this continues to inch up toward 30 degrees Celsius, and then we carry that anomalous warmth into the fall when normal temperatures would otherwise be cooling off, that's when this El Niño truly starts making its full impact felt in the atmosphere. Now, I want to take a few minutes here because I think this is the part of El Niño updates that most YouTube channels skip over, and it's actually the most important part for understanding where this is going. Let's talk about what's happening beneath the surface of the ocean, because that's where the fuel for this El Niño is being stored right now. As of May 30th, the latest subsurface temperature anomaly data, which always comes with about a week's delay, shows something that I want you to really pay attention to. In the subsurface layers of the Central and Eastern Pacific, we are seeing temperature anomalies of 4 to 6 degrees Celsius above normal spread across a large portion of the water column. And in some areas, shown in the deepest pink shading on that diagnostic map, anomalies are running at 6 to 7 degrees or more above normal. Let me just pause on that. 6 to 7 degrees above normal, beneath the ocean surface. That is not a small blip. That is an enormous reservoir of thermal energy that has not yet expressed itself at the surface. And over the coming weeks and months, as those subsurface warm waters upwell and mix toward the surface, they are going to continue to charge this El Niño event. Here's the mechanism, and I'll keep it simple. What we're observing right now is a very significant downwelling oceanic Kelvin wave propagating through the eastern Pacific. A Kelvin wave is essentially a pulse of warm water that travels east along the equator just below the surface. A downwelling Kelvin wave suppresses the normal upwelling of cooler, deeper water, which means the surface water doesn't get refreshed with cold water the way it normally would. The warm water sits, it builds, and eventually it surfaces and strengthens the El Niño further. The thermocline index, which measures the depth of the boundary between warm surface water and the colder, deeper ocean, has become exceptionally negative right now. In plain terms, the warm layer of water is very thick and very deep, and the cold water that would normally moderate sea surface temperatures is being pushed way down. The bottom line from a subsurface standpoint is this. There is nothing in the current data that suggests this El Niño is going to weaken. Everything beneath the surface says it is going to intensify, and intensify significantly, between now and peak winter. We are also expecting another downwelling oceanic Kelvin wave to develop sometime in mid-June, consistent with a standing wave pattern that's locked in near the international dateline right now. That's more fuel in the pipeline. Now here's the question that always comes up in these updates, and it's the right question to ask. Warming sea surface temperatures are one thing, but is the atmosphere actually responding to them? Because an El Niño is only fully declared when the ocean and the atmosphere are talking to each other. The answer right now is a very clear yes. The atmosphere is responding. Let's look at two key indicators. First, the Southern Oscillation Index, the SOI. This metric compares atmospheric pressure patterns between the eastern Pacific and Indonesia/the Indian Ocean. When the SOI is negative, it means pressure is lower over the eastern Pacific than normal and higher over the western Pacific, which is the classic El Niño pressure signature. When the SOI hits -7 or lower, that's when El Niño is technically considered to be influencing the atmosphere. As of our most recent reading, the SOI is at -17.33. That is more than double the threshold for El Niño atmospheric influence. The 90-day average is running at -8.44, which already exceeds that -7 threshold on a sustained basis. And the daily reading at its most extreme recently hit -36. That is an extraordinary atmospheric signal. Second, the Velocity Potential Anomaly, the VPA. This is a measure of large-scale atmospheric circulation patterns. Right now, the VPA is showing exactly what you'd expect to see. Actually, what you'd fear to see, with a strong El Niño. Significant divergence in the upper-level atmosphere over the central and eastern Pacific, and strong convergence and sinking over Indonesia, Africa, and the Indian Ocean sector. Why does that matter? Because that sinking motion over those regions is what suppresses rainfall and tropical activity in those areas, which means a drier monsoon season for parts of India, a drier and less active Atlantic hurricane season, and continued drought risk across Indonesia and parts of Australia. On the other side of that circulation, rising motion, moisture, and enhanced storminess over the central and eastern Pacific. That's the El Niño Walker circulation in full operation. There is one more atmospheric feature worth discussing here, and that's the MJO, the Madden-Julian Oscillation, which is essentially a pulse of enhanced tropical rainfall and cloudiness that travels around the tropics every 30 to 60 days. Normally, the MJO helps drive week-to-week variability in weather patterns, but right now, something unusual is happening. The MJO appears to be getting suppressed and made incoherent by the El Niño itself. What we're seeing instead is an El Niño standing wave locked in near the international dateline, meaning instead of the MJO propagating eastward the way it normally does, the tropical convection is just sitting there. It's stuck. And that standing wave is going to continue to drive westerly wind anomalies and additional westerly wind bursts across the central and eastern Pacific through at least the middle of July. Those wind bursts, as I mentioned earlier, will trigger yet another downwelling Kelvin wave, more fuel for the fire heading into fall. All right, let's get into the model guidance, because this is the part everyone comes to these videos for, and I want to be as thorough and honest with you as I can be about what the models are actually showing. Let me take you on a quick historical tour of the ECMWF, the European model, and how its forecasts for this El Niño have evolved over the past 6 months, because this evolution tells a really important story. Back in January 2026, the Euro was actually underestimating this event. The ensemble guidance was suggesting this El Niño would be fairly modest, nothing historic. February, same story. March, that's when things started to shift dramatically. The model ensemble began climbing steeply, and the current event was tracking at or above the upper end of the forecast envelope. By the April 1st forecast, the alarm bells were really starting to ring. By May 1st, the ensemble mean for the Niño 3.4 index was projecting a peak of around 3.1 degrees Celsius. Now, the euro has had to move its forecast envelope downward, not because the El Niño got weaker, but because the actual observed values are now tracking near or above what the ensemble previously showed as its upper extreme. Let that sink in. The June 1st ECMWF forecast, the most current we have, is showing something I genuinely had to look at twice. The ensemble mean for the peak of this El Niño is now sitting at 3.8 degrees Celsius on the Niño 3.4 index. Almost all ensemble members are showing at least 3.0 degrees Celsius, and a meaningful portion of those ensemble members, not a fringe outlier, but actual plume members, are showing 4.0 degrees Celsius or higher. For context, the 2015-16 El Niño, the strongest on record at the time, peaked at approximately 2.6 to 2.7 degrees Celsius. The legendary 1997-98 El Niño peaked around 2.5 degrees Celsius. What we are potentially looking at here, if the models verify, would shatter every historical benchmark we have. We have already passed what I'd normally call the spring predictability barrier, which is the period in spring where El Niño forecasts are historically least reliable. We are now over 98% past that barrier, and the models have not backed off. They have intensified. The CFS V2, the American Operational Seasonal Model, is showing a somewhat more conservative but still remarkable peak of around 3.0 degrees Celsius, with some members reaching 3.5 degrees Celsius. Even the more conservative American guidance is projecting something warmer than any El Niño in the observational record. And then there's the Tony Index, the Tropical Ocean Northern Index, which is peaking this at 3.6 to 3.7 degrees Celsius as of latest guidance. Let me give you my probability breakdown right now, updated for June 7th. 100% probability of a moderate El Niño. We're already there. 85% probability of a strong El Niño developing by late fall. 70% probability of a very strong El Niño by late fall. 40% probability of a super El Niño, meaning peak Niño 3.4 anomaly exceeding approximately 2.5 degrees Celsius on a sustained seasonal basis. 20% probability of what I'm now calling a historic El Niño, 3.0 degrees Celsius or above on the seasonal index, an event with no modern precedent. NOAA's own operational system is placing a 97% probability that this El Niño will be a significant event by late summer into early fall. That figure was sourced from their latest update through May 2026. Their June update should be out in the next week or so, and I expect those probabilities to only go up. Alright, so we've established what this El Niño is doing in the ocean and the atmosphere. Now let's talk about what it actually means for you, for weather patterns, for rainfall, for temperatures across North America and beyond. I want to be clear that what I'm sharing here is a preliminary outlook, not my official winter forecast. That's coming in a later update once I have access to the full temperature anomaly guidance. But based on what the raw model data is showing right now, here's the picture. California and the American West. A strong to historic El Niño almost universally means a very wet winter across California and the broader Southwest. What drives that is a supercharged subtropical jet stream blasting across the Pacific, combined with an enhanced Aleutian low, a persistent area of low pressure over the North Pacific that acts like a highway for Pacific storm systems. With an El Niño of this magnitude, that jet stream becomes exceptionally powerful. We could see atmospheric river events of historic intensity. Individual Kelvin wave-driven upper-level lows could break off from the polar jet and make direct hits on California. Record-shattering rainfall anomalies are on the table for California, southern Nevada, and the broader Southwest for the December through February period. The deep south and southeast, same story. The subtropical jet extends well into the Gulf Coast region during strong El Niño winters. The European seasonal forecast is explicitly showing above-average rainfall anomalies across the southeast. Parts of Florida could see record rainfall anomalies during this winter season. Flooding will be a real concern. The northern tier and northeast. El Niño winters typically bring a Canadian blocking pattern, a persistent ridge of high pressure over Hudson Bay that deflects cold air northward and keeps the northern United States and Northeast milder than average. If this El Niño reaches the magnitude being modeled, I would expect a notably warm and dry winter across the upper Midwest, Great Lakes, and especially the Northeast. If you're hoping for a snowy winter in New York or New England, this is not shaping up to be that year. The Atlantic hurricane season. I need to spend a minute on this because I know a lot of people are watching for hurricane season coverage. The short version is, El Niño is the Atlantic hurricane season's worst enemy. Strong El Niño events generate strong upper-level westerly wind shear across the Atlantic basin, which physically tears developing tropical storms apart before they can intensify. Combined with the suppressed rainfall anomalies we're already seeing over Africa and the Caribbean, where tropical waves originate, and the increased Saharan dust outbreaks being forecasted, this Atlantic hurricane season is shaping up to be significantly below average. I would not be surprised at all if we see fewer than 6 named storms this Atlantic season. That would be an extremely quiet season by modern standards. Compare that to some recent hyperactive seasons and the contrast is stark. Meanwhile, the Western and Central Pacific typhoon season is going to be a completely different story. Extremely active, potentially hyperactive, as enhanced convection over those regions fuels intense tropical cyclone development. India and the monsoon. El Niño is historically associated with a weakened or disrupted Indian summer monsoon. With the intensity of this event, there is real concern about below-normal monsoon rainfall across parts of India, which has significant implications for agriculture, water resources, and heat stress across the subcontinent. This is something I'll be monitoring closely in upcoming updates. Indonesia and Australia. Both regions face significant drought risk during El Niño events. The stronger the El Niño, the more severe the drought signal. This is one of the most reliable teleconnections in all of climate science. With an event of this potential magnitude, serious drought and fire weather conditions are a real threat across northern and eastern Australia and much of the Indonesian archipelago. I want to close this update with something I don't say lightly, and I want to be careful not to sensationalize this, but I also have to be honest with you. If this El Niño verifies at or near what the models are currently projecting, we will be in territory that has no modern analog. The 4 super El Niño events we typically reference, 1982, 1997, 2015, 2023, all of them are already behind where this event currently sits on the temperature trajectory curve. All of them. The category I've now added to my probability breakdown, historic El Niño, 3.0 degrees Celsius or above, is not a category I ever expected to need. The observational record doesn't have a clear reference point for what a 3.5 or 4 degrees Celsius El Niño looks like in terms of real-world weather impacts. Climate scientists have models, they have projections. But lived, observed experience of an event at that scale, we don't have it. That is not to panic anyone. Weather is always uncertain, and there are scenarios where this event moderates. But I owe you honesty about what the data is actually showing, and right now, on June 7th, 2026, the data is showing something genuinely extraordinary.